as being just a real valued parameter in the given condition. So I'll write down k as a member of the real numbers. And I'm pretty sure it would work for complex numbers too. I don't see any problem in the way it developed. So we could actually create problems that had complex numbers explicit here if you wanted. Okay. Now, what we did, our very first step is to actually expand out this, because when we expand this out, we actually get part of the object that we're trying to evaluate. Now notice that right here in this expansion, you would get 2, I'll try to create some room here, 2a, all right, and then to make it more readable here, I'll just go ahead and use parentheses, times 2 over a. That should read 2 divided by a right there. And again, a lot of you probably see this, and this is probably unnecessary, but notice that what happens right here is that these a's cancel, right? This a cancels with this a, and all we're left with is the 4 that you see right there, okay? So that's the first part. Now, doing that, you see we get a nice representation for what we're trying to find. We have a squared plus 4a squared, which is the object we're trying to evaluate, equals to this binomial squared minus the 4 that you see right here, okay? Now I just write it in reverse here to be more explicit. So we're right here trying to evaluate this. Now, so what's next? Well, notice that right here, 2 over a, you can rewrite this just using our given information, right? Or so when you expand this out, this is a plus 2 over a, but that's equal to a minus k, folks, right? Like right here, if you divide a right here under the 2, you get 2 over a is equal to a minus k, which is exactly where this came from, okay? Then I didn't show every bit of that, but it's just that one extra step. Divide this by a, and you get 2 over a is equal to this. And so that's all I did right here is I physically substituted this and replaced it with what it's equal to based on the given, okay? All right, now the next part involves just some expansion, okay? This would be 2a minus k squared, and that's exactly what these 4 terms are, okay? Now notice I greened this out, and notice that the reason I did that is because this part right here is just equal to 4a times a minus k. Let me get started around here. Yeah, so that's 4a times a minus k. And y'all, that's just the green part factoring 4a out of it. But notice that a times a minus k is just equal to 2, right? A times, I wish I could keep this, can I keep it on the same screen? Yeah. So a times a minus k is equal to 2. So 4 times that is the 8 that you get right there. Okay, so that's kind of nice. That's where we're using that initial condition again. And so what we get right here is that this is equal to k squared plus 4. Right, 8 minus 4 is certainly 4. So folks, a squared plus 4 over a squared is equal to k squared plus 4. And that's the truth in general. Now, and so that's the end of what I wanted to show, but let's go ahead and just work a concrete example here. What if we just arbitrarily, let's say, let me think of a number I can do here. Let's say that k was 13 at the beginning of the problem, okay? So let's choose k equals 13. Okay, and y'all, again, the k, this is just out of our sight here, but the k is this value right here. So we're choosing this k to equal to 13. All right, and so what we get right here is this would be equal to 13 squared plus 4. All right, let's see, 169 plus 4 is equal to 173. So again, this is just a special case. And you will appreciate this if you actually tried to solve that directly, meaning solve for a. So this is 169 plus 4 is 173. Okay, for the special case k equals 13. And again, all this algebraic work we did eliminates the need to actually, this would be a quadratic right here. If this was 13, this would be a squared minus 13k equals 2, and you'd end up with some surds, some irrational surds, and then you would have to plug one or both of them back into this expression. So you could solve here, but then you're having to square these irrational surds. It's not particularly difficult, but anyway, it's kind of nice how the parameter k just falls out in all this processing, and we get that this expression that we're interested in is actually just equal to that parameter squared plus 4. Okay, folks, hope you enjoyed.